Okay, today we are going to discuss the four major types of drainage patterns. I trust you've already read the chapter, so you recall that a drainage pattern is the arrangement of channels that carry water in any area. And these patterns can be very distinctive since they are determined by the climate, the topography, and the composition of the rock that underlies the formations. So consequently, we can see that a drainage pattern is really a good visual summary of the characteristic of a particular region, both geologically and climatically. In other, in other words, when we look at the drainage patterns, we can draw conclusions about the structural formation and relief of all around us, as well as the climate. Now, all drainage systems are composed of an interconnection network of streams, and when we view them together, they form distinctive patterns. Although there are at least seven identifiable kinds of drainage patterns, for our purposes, we are going to limit our study to the four major types. Probably the most familiar pattern is a dendritic drainage pattern. Dendritic, dendritic drainage pattern. This is a stream that looks like the branches of a tree. Here's an example of a dendritic pattern. As you can see, it's similar to many systems in nature. In addition to the structure of a tree, it also resembles a human circulation system. This is a very efficient drainage system because the overall length of any one branch is very short, and there are many branches, so that allows the water to flow quickly and efficiently from source or sources. Okay, let's look at the next example. This drainage pattern is referred to as a radial pattern. Notice how the streams flow from a central point. This is usually a high mountain or volcanoes. So um, it kind of all looks like the spokes that radiate out from the hub of a wheel. And when we see a radial pattern, we know that the area has experienced the uplift and that the direction of the drainage is down the slopes of the relatively isolated central point. Going back to the dendritic dendritic for a moment. The pattern is determined by the direction of the slope or of the land, but streams flow in more or less the same direction, and so it's unlike the radial that has multiple directions of flow from the highest point. Now, this pattern is very different from either the dendritic or the radial. This is called a rectangular pattern. And I think you can see why. Just look at all of those right angle turns. The rectangular pattern is typical of a landscape that's been formed by fractured joints and folds. And because this broken rock is eroded more easily than a broken rock, stream beds are carved along the jointed bedrock. Stream beds are curved along the jointed bedrock. Finally, we have the trellis pattern. And here in this example, you can see quite clearly how the tributaries of an almost parallel structure drain into valleys and form the appearance of a garden trellis. This pattern forms in areas where there are alternating bands of variable resistance, and by that I mean that the bands of rocks that are very strong and resistant to erosion alternate with bands of rocks that are weak and easily eroded. This often happens when a horizontal plane falls and outcroppings appear. So as I said as a whole, these patterns are dictated by the structure and relief of the land, the kinds of rocks on which the streams are developed, the structural pattern of the folds and uplift will usually determine a drainage system. However, I should also mention that the drainage pattern can occasionally appear to be well out of sync with the landscape. This can happen when a stream flows over older structures that have been uncovered by erosion, or when a stream keeps its original drainage system when rocks are uplifted. So when that happens, the pattern appears to be contrary to the expected course of the stream. But I'm interested in your understanding the basic drainage system, so I don't plan to trick you with test questions about exceptional patterns. But I expect you to know that exceptions to the pattern can occur when geological events influence them. まあまあ